Alright, thank you for reaching this far. I believe this should be video number 4 now, and we are going to be doing some of the examples that lie under the category of Pythagoras theorem, the subtopic of Pythagoras theorem. One of the applications, like I stated at the beginning, is we're going to keep talking about finding angles in between a particular range time and again, but there are different questions that are going to come here, and one of the concepts that we have to explore in order to be able to attempt each and every question is the Pythagoras theorem. So our examples this time around are coming from the pure one still by Backhouse and exercise number 16b. Now I'm going to do number 8 together with another number, a second number, and I'll leave the rest for you to do. So our number is 3 minus 3 cos theta is equals to 2 sine squared theta. We are to find other angles of theta in that particular range of 0 up to 360 inclusive. Now from the trigonometrical identities we had the first one as sine squared theta plus cos squared theta. Our aim here is to replace for one of those trig functions, because the relationship between cos and sine only comes through the first trig identity. Okay, so if you now make sine squared theta the subject, you obtain 1 minus cos squared theta, and once you substitute that in the equation that you have been given above, you come out with this particular equation: 2 cos squared theta minus 3 cos theta plus 3 is equal to, minus 2 is equal to 0. And that looks so familiar to what we have been doing. So we have only added in one concept, that if you have been given two trigonometrical functions that are different, you find a trig identity that relates those two. Okay, that relates those two, then substitute in for one of the trig functions to obtain an expression which only has trigonometrical functions of one kind. So this time around we spotted out the cos squared theta. Okay, so when we now say let cos theta equal to x, that is a mistake, it's not cos squared theta, it is cos theta is equals to x. Please correct it. So if we say that letting cos theta be equal to x, you realize that the equation above turns into a quadratic equation in terms of x, which is 2x squared minus 3x plus 1. So we find two numbers, when you add them you get negative 3, multiply them, get 2, that is negative 2 and negative 1. When we solve that quadratic equation, we come up with x minus 1 into brackets 2x minus 1 is equal to 0. So you now realize that either x minus 1 is equal to 0 or 2x minus 1 is equal to 0. So we end up with those two values of x, either x is equals to 1 or x is equals to a half, and when you substitute in cos theta, we shall have cos theta is equal to 1 or cos theta is equal to a half. So we're now going to solve for those particular angles. Now when we consider the first one, when we consider cos theta is equal to 1, you realize that when you obtain the arc cos of 1, we get theta is equals to 0 degrees, and that's what we call the principal value. And so if I'm interested in finding other angles given the principal value of 0 degrees for theta, we put in our equation the formula, the general formula we wrote down: cos theta is equals to 360n plus or minus theta. When you put there 0, you'll now have that for n is equal to 0, theta will be equal to 0 degrees, n is equal to 1, theta will be equal to 360 degrees, and when n is equals to 2, theta will be outside range. Alright, so we now consider for cos theta is equals to a half. When you get the arc cos of a half, that is 60 degrees, and that's another principal value. So we still use the same formula for cos theta is equals to 360n plus or minus theta. And so when you put in for theta 60 degrees, when n is equal to 0, theta will be equal to 60 degrees. When n is equal to 1, theta will be equal to 300 degrees. And when n is equal to 2, theta will be outside range. Therefore, our angles beginning from the smallest to the biggest are going to be 0 degrees, 60 degrees, 300 degrees, and 360 degrees, and those are going to be our answers. Alright, so I'll attempt one more number, and that's number 11 from the back house. It still talks about the same concept. This time around you have been given cosec squared theta is equals to 3 plus cot theta, 3 plus cot theta. So there is one trig identity that relates cosec with cot, and if you remember, it's the one that it was the first one where we divided through by sine squared theta using the first trig identity. So you realize that cosec squared theta is equals to cot squared theta plus 1. And when you substitute that into our equation, you obtain cot squared theta plus 1 is equals to 3 plus cot theta. So when we let cot theta equal to x, you'll obtain a quadratic equation in terms of x. A quadratic equation which is x squared minus x minus 2 is equal to 0. So two numbers, add them, get -1, multiply, get -2, that is 1 and -2. When we solve down that quadratic equation, we come up with this expression. We come up with x plus 1 into x minus 2 is equal to 0. So either x plus 1 is equal to 0 or x minus 2 is equal to 0. Remember that law only applies to 0, okay? So either x is equals to -1 or x is equals to 2. So when we substitute back for x being equal to cot theta, you realize that cot theta is equals to -1 over tan theta, because cot theta is equals to 1 over tan theta. You realize tan theta is equals to -1, and on the other side you also have cot theta is equals to 2, and 1 over tan theta is equals to 2. Therefore, tan theta will be equal to a half. So considering tan theta is equals to -1, when you get the principal value theta, getting the arctan of -1, we obtain -45 as our principal value. So from the formula, tan theta is equals to 180n plus theta. When you replace for theta is equals to 45 degrees, you obtain other angles of theta being, when n is equals to 0, theta is outside range because it's -45. When n is equals to 1, theta will be equals to 135 degrees. When n is equals to 2, theta will be equal to 315 degrees. And when n is equals to 3, theta is outside range. So likewise, we obtain the principal value for tan theta is equals to a half. And when you get the arctan of a half, you'll get 26.57 as our principal value. Remember, angles are put up to 2 decimal places. So we simply substitute into the same formula that theta is equals to 180n plus 26.57 degrees. When n is equals to 0, theta will be equals to 26.57. When n is equal to 1, theta will be equal to 206.57. When n is equals to 2, theta will be outside range. So you now write all the values of theta to get the final answer marks, beginning from the smallest to the biggest. So I'm going to get into another video and look at other examples that exploit the concept of Pythagoras theorem. Thank you, hope to see you there. So please don't forget to subscribe onto my YouTube channel for more videos, and please, if you like the video, put a thumbs up. Thank you.